Basic examples! Okay, today we're going to talk about factoring, okay? So when we add and subtract numbers, we think of their parts as being added up. For example, 144, that's 104 tens and 4 ones, okay? And this is the sort of thinking that we use when we're talking about long addition or something like that. So, for example, if you want to do 144 plus 83, you think, okay, that's 100, 4 tens, 4 ones, plus 8 tens and 3 ones. 4 ones and 3 ones is 7 ones. 4 tens and 8 tens is 12 tens. Okay, you also need to know that 10 tens is 100, and 10 hundreds is 1,000, and so on. So you can take those 10 tens, turn them into 100, and then in shorthand, you say 4 plus 3 is 7, 4 plus 8 is 12, carry the 1, and then you put your 2 down. Very, very simple. So that's how long addition works. And so when you're adding numbers together, you think of them as being added. However, when we multiply or divide numbers, it's really, really useful to be able to think of them as things multiplied together. And this is called factoring. For example, 20. How is 20 made as multiplying together? Well, it's 4 times 5, it's 2 times 10, it's a lot of different ways. 10 times 2, that's one of the ways of doing it. 45, many ways to do it. 9 times 5 or 15 times 3. 15, well, if we're not going to use 1, it's got to be a 5 and a 3. And this is sort of the big idea. A number that can't be factored down any further, if you don't use 1, is called a prime number. And any number can be factored down into a unique collection of prime numbers. With big numbers, this can be incredibly difficult. In fact, it's the basis behind computer security in some ways. But with small numbers, it's not so hard, and it's really useful to learn these. Here's some tricks. Any even number has a 2 in it. Any number that ends in 0 and 5 has a 5 in it. And the last one you need to know, if you add up all the digits of the number and you get something that's divisible by 3, then the whole number is divisible by 3. Kind of weird, but true, and I'm not going to prove it here. It really helps to master the factorization of a few basic numbers. If you've got 4 down and 6 down and 8 and 10 and 12 and 15, 20, 100, numbers like that. Just a few numbers. If you can really just look at the number 50 and you think it's got 5s in it, it's got a 2 in it, that really, really is helpful. There's 2 main ways for people to factor. The wedding cake method is you put the number down at the bottom of the page and you say, wait a second, 1 plus 1 plus 7 is 9. That's divisible by 3. There's a 3 that goes into the whole number. 3 goes into 11 twice, 3 times with a 2 remaining, and then 3 goes into the 27 9 times 39. You can do a longer division if you want. 39, 3 plus 9 is 12. That's got a 3 in it. So 3 goes in neatly with a remainder of 13, which is prime. So you say 117. The prime factorization is 3 times 3 times 13. A lot of people are taught the tree method. You take a number like 80, you say, well, there's a 2 in it, so 2 times 40. 2 is prime, but 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. And now we're done. All the little leaves on the tree are prime, and so we can just say 80 is 4 2s and a 5 all multiplied together, or if you want to use exponents, 80 is 2 to the 4th times 5. This is factoring, and this is so useful in mathematics to just have a basic understanding of factoring just for these small numbers. It'll take you so far.